Hi, my name is Wibowo, and I'm a software engineer at Airbnb, and today I'm going to talk to you about knitting. Before you get up to leave because you think you might be at the wrong conference, I want to reassure you that this talk is also about problem solving and hardware hacking and even has some code. You're just going to have to wait to see how. I'll start with an inspiration, and here's a somewhat unexpected inspiration of this journey. A few years ago, a video game review site called Kotaku published an article about Super Nintendo add-ons that didn't quite make the cut. You've probably heard of some of the outlandish Nintendo peripherals that did make the cut: a baseball bat for playing baseball video games, a golf club for golf games, Super Scope wireless gun for shooting games. But you might not have known that Nintendo was seriously contemplating making a knitting add-on. Here's the proposed advertisement for the knitting add-on, complete with horrible puns. I'm not sure if you can read, but on the bottom right corner it literally says, "Why needle the competition?" So the interface would be just like Mariopaint, but instead of pictures as output, you'd get your design on an actual scarf or mittens. Most of the comments left on the Kotaku articles were along the lines of, "Lol, we can totally see why this never made it to production," or "What were they even thinking?" But I had a really different reaction to hearing about this add-on that never made it. I was so disappointed. I would totally use one all the time if I had one, and I just kept trying to think of how I could make this a reality. So I did some research. Did Nintendo make any prototypes that I could get my hands on? Did any other company make electronic knitting machines for home use? After a lot of research, it turned out that in the 1980s, there was a whole line of electronic knitting machines that were made, but then discontinued. So that's when my dream was born, to get my hands on one of these and make something like the Nintendo knitting machine add-on that never was. As fate would have it, there was one of these super old knitting machines on sale on Craigslist at an address an hour and a half away from me. It was old and it was broken and parts were missing, but it was the start of something. It was the start of my dream. And to reiterate the dream again in cartoon form, the dream was to have a knitting machine that could take images from a computer and turn them into sweaters, basically to create a networked yarn printer. So now that I had gotten hold of one of these machines, the first thing I needed to do was to learn how to use the damn thing, because just figuring out how to use the basic built-in functionality of the knitting machine, let alone hacking it, was daunting. Because this is what a knitting machine looks like. There are 200 knitting needles that move in and out, and you thread however many needles as you want your knitting to be wide. There are mechanisms to thread up to 2 different colors of yarn through the needle, and alternating the 2 colors of yarn creates patterns. And if this is what using a knitting machine looks like, this is what using a knitting machine feels like. There are so many buttons and moving parts, and the machine comes with a really thick manual with lots of unfamiliar terms. And it totally felt like operating the control station of a starship. And I was worried that if I pressed the wrong thing that this would happen, or at least that I would break some of the needles on the machine and have no idea how to fix it. Luckily, I had a team of people to help me face the knitting machine that was both fearless and inventive. This is the team of Airbnb engineers that helped hack a knitting machine for last year's Airbnb Hackathon. Airbnb hosts internal hackathons twice a year for the entire product team, both designers and engineers. Wait, Airbnb Hackathon, you ask? What does knitting have to do with traveling? I asked the hackathon organizer if this was a valid project to work on during the hackathon, and they told me, well, the spirit of the hackathon and our engineering culture is about creating awesome things that are useful to people, and this project sounds pretty awesome and useful. So I was approved to work on hacking a knitting machine. I had no idea if anyone else would be interested in working on this ridiculous project with me, so when I pitched it, I was surprised that there was so much interest. The people who came up to talk to me saying that they wanted to be on my hackathon team were as excited or even more excited than I was. And there were so many different kinds of engineers that came to talk to me about it: an iOS engineer, an SRE, a performance engineer, a data infrastructure engineer, a front-end engineer. And this is all to say that we were a bunch of engineers who knew nothing about knitting or knitting machines. But my knitting teammates were all super amazing and super excited, and it was one of the best and most productive teams I've ever worked on. I think this was partly because we had zero ego attached to machine knitting. None of us knew how to knit or machine knit, so this was just kind of a wild adventure we were all in on together. So the reason we had to be fearless was that the knitting machine was really daunting, and it was a problem we had no idea how to solve. And inventive because this was technology from the 80s, and the machine that we had was missing some of its parts, and we had to MacGyver replacement parts. And the good thing about being an engineer is that you can apply your problem-solving skills to almost anything, including knitting. So this is an example of a problem that needed to be solved by being resourceful and inventive. It seemed like we were encountering problems on every step of our journey, even before turning the machine on. Just preparing the yarn for the machine was hard, because when you buy yarn at a yarn store, it's optimized for hand knitting, not machine knitting. And in order to feed the yarn into the machine, it has to be wound into a spool from which it will unwind neatly and feed into the machine at an even rate. And our machine had come with a contraption to turn balls of yarn into spools, but it was missing some parts, so we had to MacGyver a solution from a coffee cup. And this is Dave, one of my teammates, spooling yarn with our MacGyver coffee cup spooler. So after we learned to set up the knitting machine and successfully knit plain rows of plain color, the next step was to learn how to use the machine to knit the built-in patterns. Since you can feed up to 2 different spools of yarn into the machine, the knitting machine has some patterns built into its memory, and it comes with a book listing all of the patterns and the numbers that you can input to use those patterns. And even though this was something that was already built into the machine and not any additional functionality we were adding, it still seemed like a huge and daunting step to us, because there was twice as much yarn, meaning twice as much yarn to get tangled, and it required reading an additional 20 pages of the knitting machine manual. It just seemed like the next level up in machine knitting. Just to show you how non-trivial this was, on the left is our first attempt to knit a built-in pattern, which looks super ugly as a result of pressing some of the wrong buttons, using the wrong yarn settings, and accidentally skipping some needles. And a few hours later, we successfully knitted the polka dots that you see on the right. And I wish that there was a photo of how elated we look when we successfully use the machine's built-in patterns. Another example of engineering problem solving necessary for knitting was when we would knit patterns, we would notice that the yarn would get stuck more often than when we were knitting just solid colors. So we would try different yarns and different settings and write down the results and form hypotheses for what types of thicknesses of yarn we should try next and what settings. And so eventually we learned the right thickness that we needed to use, and also observed that animal yarns had natural oils that kept them from getting tangled in the machine so much. But after we had figured out how to knit the machine's built-in patterns, we hadn't achieved our dream yet. As far as we could tell, the intended user of a knitting machine was a grandmother from the 80s, and so the built-in patterns were things like bows and teddy bears. And I don't know about you, but I would rather have a sweater with Grumpy Cat on it than a teddy bear, so we still wanted to figure out how to send the knitting machine our own images, which is step 3 of our goal. And this goal would be split into several parts. Because it's from the 1980s, the knitting machine takes additional patterns via a floppy drive. Back then, you could buy additional pattern packs on floppy disks. So we could send our own images to the knitting machine by putting them on an emulated floppy drive. So we wanted to emulate a floppy drive in software, and then we needed to build a custom cable, the serial cable that would have connected the floppy drive to the machine, but will now instead connect our fake floppy drive to the knitting machine. USB to knitting machine serial port. And we had to make this cable custom because the knitting machine had a really weird pinout. But thankfully we found documentation for the knitting machine's pinout and also used a library that emulated a floppy drive. And then we wanted to convert our input images into low-res 1-bit bitmaps, which is the file format that the knitting machine takes. There are a few different ways to do this, but we wanted to include a conversion algorithm that supported dithering, and we also were lucky to find a library for this piece. And then we could have the knitting machine read from our computer as if it were floppy drive. Here's one of our first custom patterns. Note the dithering on the she that you knew. It's hard to read, but it says, wow, oh my god, such fair isle, which is a type of knitting stitch. And here is a grumpy cat. So we were having entirely too much fun with this, but we didn't want sending pictures to the knitting machine to be limited to just us, who had hacked on it and studied the manual. We wanted anyone to be able to print memes from yarn, and we wanted to share the fun we were having. So the next step was to make knitting machine image upload available on the web. It would be a super simple interface. You choose a photo to upload, send the image to the machine, and it would give you instructions for the buttons to press on the machine to start knitting your pattern. And here's a video of the whole thing in action. So this is a close-up of the input image and knitted output in case it was too small to see in the video. And now we can look at the code that made this possible. It's in Ruby and Sinatra, and it's super simple. So we require Sinatra and Haml, and we've wrapped the libraries that convert images to 2-bit bitmaps and the floppy disk drive emulator library that we call pattern disk drive. So when the user presses the upload button, we save the user's photo to a file, use the image processing library to convert the image to a 1-bit bitmap, and start emulating the floppy disk drive. And then in the web browser, we display instructions for the user for what buttons they should be pressing on the knitting machine. And this is the view for the upload form. So the things that we learned from this adventure. First, we gained mad respect for grandmothers and anyone who knits, because that shit is hard. I recall so many moments where my teammates said things like, I thought my job was hard, but optimizing database queries ain't got nothing on this. Another learning that we had is that teams work really well when everyone operates with zero ego at stake. Also, it's really enjoyable to apply Ruby to any of your hobbies, no matter how unrelated they might seem, especially hobbies related to creating. I challenge you to find a hobby that seems more unrelated to Ruby than knitting, but even with knitting, it was possible. And also, when you start exploring the union of technology and your hobbies, you discover how strangely similar they are. I would have never guessed that I would be making off-by-one errors and knitting too. Also, it feels really great to take up something that you know nothing about. So many of my teammates said that it was one of the most fun and challenging things that they had worked on all year. Learning something brand new and very different from what you do day to day is humbling and challenging and refreshing. And it reminds you what it's like to be a beginner, which is important to gain empathy with new programmers that you might work with or teach or mentor. And there is still a lot left to do and explore in the whole space of computing and knitting. And the amazing thing about giving this talk at conferences is that at every conference, people have talked to me about even more ideas for how to take knitting machine hacking further. On the web interface axis, it would be great to make an interface where you could draw an image and send that to the knitting machine without needing to use an already existing image, and previews for what your design might look like in different colored yarns. Another goal I had for a while after hacking the knitting machine was learning how to use the machine itself better to knit whole garments, like socks and sweaters and socks with toes. And when I gave this talk last year at Madison Ruby, a programmer and knitter named Liz Abinante told me about a knitting machine academy in Seattle where they teach you how to use these old machines to make full garments. So last month, I signed up for a weekend intensive knitting academy there, and I brought my computer and my hacked cable, and I learned to make all the pieces of the sweater I'm wearing right now. And use the knitting machine hack to adorn the sweater with a doge. So sharing what you've worked on with a community and audience just makes your project even better. On the hardware hacking axis, it would be amazing to figure out how to automate more of the knitting process. An automatic robotic arm that moves back and forth would save me from having to do that. I've also been reading about hacks that replace the whole logic board of the knitting machine with an Arduino, which would be fun to try to be able to control more of the knitting machine interface. For example, showing you how much progress you've made on your knitting and how much more you have left to knit. And lastly, I would love to talk to you about any ideas you have if you care about hardware hacking, knitting, or combining code with art. So thank you so much for listening and having me here.